Your body in space. Your body's pretty amazing at adapting to new environments, but space does some strange things. Apart with getting taller, which a lot of people will hear about, your digestive system gets a little wiggy. Let's say you eat food here on Earth. Very simply, you put the food in your mouth, it goes down, gravity pulls it down to the bottom of your stomach. Your sandwich, it's pretty heavy, it'd be down at the bottom. Your drink would be the next layer, and any air that you might happen to consume will slowly rise to the top, much in the same way as our little experiment here. I've just got a jar of water, I've got your normal Alka-Seltzer tablet, I drop that in, and we notice that because of gravity here on Earth, the heavy objects drop to the bottom, the lighter objects, the air, rise to the top. Now in space this doesn't happen. There's an Alka-Seltzer tablet. It goes into a floating blob of water, but if you'll notice, it's still bubbling, but they're not all going in one direction. They're going all over the place. Now what does that mean to your body? Well, it means that you don't have that sensation of the air bubbles collecting in one area, and then you feel like you need to burp. For an astronaut, that can be quite a painful feeling. The air bubbles kind of go all over the place, so if they mix together, burping would probably mean that you'd throw up a little bit. And the other thing might mean that you might see more than you really want to if you did pass a little bit of gas. Astronauts are aware of this. They don't bring up food that's going to cause them to have gas. No bean burrito, no pop up in space. But there's no way around it. That's just the way that gravity separates those things inside your body. So, let's say you do want to go into space. Well, I'm not going to send you into space right now. I'm going to send a balloon into space because it's a little bit safer that way. The vacuum of space, the fact that there's no air out in space, does some really strange things to your body. And we're going to stick Mr. Balloon Guy into this vacuum chamber. And this is as close as we can get to simulating the idea of being in a vacuum. We're going to remove the air from around the outside of the balloon, but the air that's inside the balloon is going to start to do something kind of interesting. So let me start this out. We're going to pull the air out. And you can notice that our balloon is starting to change shape. In fact, it's getting bigger. And that's because the air inside is getting a chance to expand. There's no longer any air pushing down on it, so the air inside is freed, basically. What would this mean to you out in space? A very painful end to your space trip. Of course, to prevent that, simply wear a spacesuit, and that layer of air that you carry around you will prevent that whole explosion from happening out in space. Now, if you want to learn more about how your body reacts to space, what happens to your blood, how tall you get, whether your feet change, come down to the H.R. MacMillan Space Center. For The Express, I'm Cam Cronin.